Okay, so it's time for another physics video, and this one's just about conservation of energy, so potential and kinetic. And the problem says, according to this diagram right here, hold on, that the water slide shown in the picture ends at a height of 1.5 meters above the pool. If the person starts from rest at point A and lands in the water at point B, what is the height of the water slide? And assume that the water slide is frictionless. So we're looking for this little height right here, but since the water slide ends right here, this height is 1.5. So we just want to find this one. And the length, so the person on the water slide travels and lands over here, and from the end of the slide to here, it's 2.5 meters. And so the easiest way to do this problem is going to be using conservation of energy. So it's going to be already right here, m times g times y, and that's potential energy right there. It's going to equal 1/2 mv squared, and that's kinetic energy. Because when the person is right here, let's just say it's a she, because it's a she in the original picture, she starts out at rest. She starts out with 0 velocity. So this right here would effectively be 0. So it's not kinetic energy, it's potential energy, because we have a height, we have gravity, and we have a mass. So, and she's going to end right here with 1/2 mv squared. So first you can just cancel out the masses right here, and we want to rearrange this equation so that it would be okay, I'm going to change this y to h, sorry, just so it would kind of correspond with the picture, but we want h by itself, so we would just divide this by g right here, so we would get v squared over 2g. So h is going to equal v squared over 2g. So we just need to find this velocity right here, and if we go back to our motion equations, we can figure out this velocity if we have this height and this distance right here. So we know that if you're falling for 1.5 meters, so if you have a height and you're falling down, you can calculate how much time you're spent in the air. This height is 1.5. This distance can be anything really. The time is still going to be the same because it's accelerating downwards at negative 9.8 meters per second squared. So the equation for time is, and this is only for free fall. The equation for time is 2 delta y over g. Well, the square root of 2 delta y over g, and that's going to be the square root of 2 times, and what's delta y? 1.5 meters divided by 2 times 9.8 meters per second squared, and that equals 0.55 seconds. If you put in your calculator, I already did. If we have the time and we have this distance right here, we can find out the velocity now, because the velocity is going to stay constant. It's in the air and we're disregarding friction and everything. So this velocity is going to be the same as this velocity. So we can do delta x over t equals v, and that's just the regular velocity equation, the generic one. So we would have delta x just 2.5 meters divided by 0.55 seconds, and we get 4.5 meters per second. Now if we go back to this equation right here, since we already have the velocity, we would get, let me see if this is one. Okay, we would get 4.5 meters per second, and this is squared. Right there, it's squared because it's squared in the original kinetic energy equation, divided by 2 times 9.8, which is gravity. We get 1.05 meters. So this height right here that we start out with is 1.05 meters. That's it.